Thank you for joining me and indicating some interest in wanting to learn a little bit more about LYNX MOSA.ic. We're going to go into some more of the details about the constituent parts of LYNX MOSA.ic. The hypervisor, LYNX Secure, the real-time operating system, LYNX 178, how you build simple applications, bare metal code, which we call LYNX Simple Applications or LSAs, and LYNX Element, which is our unikernel. So let's dive right in. I talked previously about LYNX Secure being that foundational piece of software for us. This is the very thin hypervisor, and as a quick reminder, there's no drivers, no emulation going on. All that LYNX Secure does is really control plane activities where we set up the different virtual machines, we allocate the policies and permissions as to what elements of hardware each of those virtual machines can access, and then pretty much LYNX Secure gets out of the way and your system runs. So as mentioned on that first bullet, we actually set up the VMs, and those are defined by an architecture configuration policy, which you set up, that is immutable. Those allocations will not change after the system boots. And, because it's really just in the control plane, there's no way that LYNX Secure executable can be accessed. There's no means for an application or any other way to get in and modify that boot code. We will talk about guest-to-guest communications because you're going to want a virtual machine mate sometimes talking to another. But as I mentioned there, on LYNX Secure, it stays out of the data plane. So the data is not passing through the hypervisor itself. What this means is it's a very secure foundational block. We believe that makes it much harder for people to take over and hack a system based on LYNX Secure, as opposed to some of the other architectures out there where the hypervisors are in the data plane and in some cases are built on an RTOS. And this, like the rest of LYNX MOSA.ic, is certified up to DO 178 DAL-A. That is the most stringent element of the DO 178 certification. We've done that certification across multiple architectures, and we'll continue to evolve and support new processors on a forward-going basis. But as of today, we've supported and taken through certification with our partners LYNX Secure and the rest of LYNX MOSA.ic on Intel hardware, the Atom part of the family, and also have a committed roadmap on the ARM architecture to take that through to DAL-A cert. Our operating system, LYNX 178, has been certified a number of times to DAL-A. We've had this operating system for in excess of 15 years. So a lot of customers have taken have taken platforms based on this technology through cert. And we focused on open standards. We believe customers really don't want to be locked into a particular RTOS vendor. And so we have the strongest alignment to POSIX as compared with any other RTOS offering. What that means is, in addition to being quite portable code between offerings, it also allows customers a very simple development path from running code on Linux and then taking only the real-time deterministic code or the safety certification code onto the RTOS for future work. So we support ARINC 653, and of incredible importance right now in the US, particularly around the Army, is FACE, alignment to the FACE standard. We're conformant with FACE 3.1 across 3 processor architectures, and FACE 3.1 is the latest and greatest version of that standard. There'll be more versions over time, and we're committed to actually keep our software up to date and conformant with the latest version of that standard. We also support 32 and 64-bit applications on the operating system. Why is that important? A lot of customers have proven code that is 32-bit only and maybe have no desire to move to 64-bit and recertify that code. So we will support those 32-bit binaries and allow customers to use those applications on new systems. It is fair to say that our push forward is around 64-bit, so we'll be adding new functionality and prioritizing that functionality onto 64-bit environments as opposed to 32. But for customers that want a nice controlled migration path, or in fact, no migration path, they just want to stay on 32-bit, we will support 32-bit operation on LYNX 178. Let's talk about bare metal code. In a previous video, I mentioned that some customers really want very small software directly bare metal. They believe that they can control timing more precisely if they're writing on bare metal, and they're right. And they're willing to actually take the extra engineering effort to plan that timing, execute that software based on their very, very fundamental understanding of the underlying hardware. We fully support that, and it really also allows any software asset to be connected to another software asset in the system. I mentioned on the Lynx Secure slide, we do not pass data through Lynx Secure. So these applications are set up either as a one-way directional communication path or a two-way directional communication path using FIFOs or other ways of shared memory to pass information from one virtual machine to another. And this allows incredible, more granular ways to set up security. So you can have an untrusted operating system bounded and having a very controlled set of communication paths into other parts of the system to allow untrusted apps and OSs to only be able to work inside a certain set of boundaries. Our newest element into the LYNX MOSA.ic product portfolio is LYNX Element, which is our unikernel. And maybe the best way to think about this is thinking about containers, where you're basically binding all of the software in one modular package. Now, we actually take sort of containerization, one step further, because even with a container, there are some reliances on other system calls and other system services. So really what a unikernel does is it pulls together all of the elements, both underlying kernel elements and the applications that are needed to run a specific service. It is multi-threaded single core. So you take that application and it's basically packaged up with all of those features in one module. What that means, in addition to, yes, no context switching and it's not blocked, the real key thing here is it's a much easier software block to define. If you know all of the elements that are responsible for running that particular block are all contained there, it's a block you can modularize, characterize, and that allows you to provide an easier path to safety certification, as well as an easier path to be guaranteeing timing and things like that. So we see this as a really key block around how customers are going to be able to reuse software across mission critical systems, something that has been lacking in this industry for a long time. I mentioned earlier that these systems are incredibly complicated, and we recognize as Lynx, we can't do everything. So this is sort of a snapshot of, depending on what other functions you need in your system, who else in our ecosystem is providing blocks of technology that we know work with LYNX MOSA.ic. So whether that's a real-time database from a MacObject or a Rhymer kind of company, or whether it's a Intel Tiger Lake piece of hardware from Mercury or Curtiss-Wright. We have a set of partners across these different buckets that again have technology that we've managed to prove interoperability works very, very well with LYNX Mosaic. I hope you found that interesting. We have a lot more details available around LYNX Mosaic. Go to more granular information about how we do real-time scheduling for virtual machines, how we support CAST32A, how we do setup of virtual machines inside LYNX Secure. The LYNX Resource Center is an open place, no registration needed, where you'll find a lot of technical blogs and articles. You can also sign up to our newsletter, where we will send you new information about what's going on with us and our partners about every quarter. And if there's something else that's burning and you want to hear about it, or something I said that you didn't understand, feel free to email me directly. I greatly appreciate your time. Thank you for being interested in LYNX and LYNX Mosaic. We look forward to helping you on future projects as we go further forward.